Hello everyone, we are Group 7. Today we are going to discuss the problem 7 of Advanced Transport Phenomena. My name is Yiting Liao. My student ID is 71130651102. These are my team members, Yixuan Lin and Xixuan Xie. So okay, let's start the topic. A fluid is contained in the annular space between two cylinders of radius kappa r and r. The inner cylinder is made to rotate with a constant angular velocity of capital omega I. Consider a line of fluid particles in the plane Z equals to 0, extending from the inner cylinder to the outer cylinder and initially located at theta equals 0, normal to the two surfaces. How does this fluid line deform into a curve theta of r and t? What is the length L of the curve after capital N revolutions of the inner cylinder? And so we can refer to the equation here.
In the next part, we will solve the theta function of theta. And with the equation of motion, the velocity distributed in the annular space can be determined. The key relationship between the curve theta and the velocity is d theta divided dt equal to phi divided r. Integrate will both sides with respect to t when get this equation. But when t equal 0, the theta is 0. So when you get theta 0 is 0. So guess the equation is here. And right now we can assume the flow only in the theta direction and the vary only in the r direction. So we get this function and the two boundary conditions. The boundary condition one is this. When the r equal kappa r, we get this. And when the r equal big R, we get this. And the next part, if we answer the flow does not slip on the wall, then it has the wall velocity as a kappa and it was. The equation of continuous resource by the considered mass base over volume. Elements are that fluid is flowing source. Also, the flow distance is constant. So we get this equation and the next step is the expression. And we look important that the phi r is equal to 0 and the phi d is equal to 0 and the phi theta of function r. So in this we can get this phi r is equal to 0. So this term is equal to 0. And the phi d is equal to 0. So this term is equal to 0. And phi theta is function of r. So this term is equal to 0. Put in the Navier-Stokes equation in the linear direction continuity. So we get three directions. It's r and theta and 0. So we import look the other theta direction because the b theta is function of r. So this term and this term and this term is equal to 0. And the phi r is equal to 0. So this term and this term is equal to 0. Because the law is a constant, so this term is equal to 0. And prefer the term. The theta is phi theta is a function of r. So this term and this term and this term is equal to 0. And the final terms we can look at this log g theta because graphically is the lead direction. So g theta is equal to 0. So we get the equation is this. And divide side by mu, we get this equation. Equates with both sides with respect to R2 times. We get the equation. And divide both sides by R, we get this. Obviously, the two boundary conditions is boundary condition 1 and boundary condition 2. We get the C1 and C2. C1 is here and C2 is here. So we arrange the phi theta R equation, we get this. And the theta function of RT, we get final answers.
By this part, our goal is to observe the curved length. Because of using the cylinder coordinate to calculate in previous process, we should convert it to polar coordinate right now, with x equals to r x equal to r cosine theta, and y equals to r sin theta. Through applying the chain rule and cosine theta squared plus theta sin theta squared equal to 1, this equation of ds will become this. Let's focus on the highlight parts. These terms in red lines and the blue boxes can become a simple one or be cancelled with each other. So we get this equation of ds squared. Take the square root of both sides, and we can get this equation of ds. Let's integrate both sides to observe this equation. In this part, we will proceed with a change of variables to simplify this equation. Make C equal to R divided to R and differentiate it to get this. Derivation and substitution. We can get the equation of curved length L. And this equation is divided both sides by R. The final answer is supposed to be in terms of n, and that means the number of resolution. By making n equal to omega multiple t and divide by 2 pi. Substitute it in this equation and expand these terms. We can get this equation. Therefore, the length of the curve after n revolution of inner cylinder is this equation. Our derivation is over. Thanks to pay attention.